So hello everyone, and today we'll be seeing one of the very deceptive problem which is asked within an interview, which is product of array except itself. Yeah, it seems very simple at the first glance. The solution is also simple, but wait a second. If you implemented the solution, you might not be within the best chances to crack the interview. But if you wanted to crack an interview in a topmost category in a best cream portion, you have to watch this video till the end because there are few facts which are within this problem, and interviewer often at times acts nasty. I'll let you know how. First of all, let's get into the problem. So the problem is very simple. It says given an integer an array which is nums, return an array answer such that answer of I is equal to the product of elements of nums except nums of I. So except the current element, I wanted a product of every element. Sounds very simple. The product of prefix of a sum, prefix or suffix of nums is guaranteed to fit in 32-bit integer, and you must do it in O of n time without using the division operator. And this is what the crux lies, without using a division operator. Well, in an interview, you would be only given this line and not these two lines. So we would assume that hey, these two lines are not provided to us yet. And this is the sample example, and you can check, verify 2 into 3s are 6, 6 into 4 is 24, and that's what 24 is, and the rest is all same. And yeah, now the question is how we can solve this problem. Well, there are few approaches to this, and you have to do the same thing. The first of all, you need to explain the brute force solution, because you need to break the ice and let the interviewer know that hey, you're not just thinking over even the brute force solution. You know the brute force solution, but you are optimizing it. You are thinking to optimize this solution. You are not settling upon the brute force, and that's what they want. The brute force solution, as usual, you know that it's very simple. O of n into n, where for each element within an array you iterate the other n elements, n minus 1 elements, and that's where the time complexity becomes n into n, and the space complexity becomes O of 1, because no space is used. Now there is a second solution, which is division. You say, hey, I would do one thing, that I would carefully multiply each and every number. So I'll multiply the array, and for each element a of I, the subsequent result would be nothing but multiply divided by a of I, and that's it. And yeah, this can solve the problem. But now, and again, for this solution you have a time complexity of O of n and space complexity of O of 1. But this is where things get interesting, and interview says you that hey, do not use division operator. And the reasons he mentioned is weird. He would say that hey, division operation is costly, you cannot divide, division is not supported, the thread is locked, and whatnot. I am not sure why, but yeah, division is not used. So you are into a situation now, you have to solve this problem without using division. You cannot jump into brute force, because you have already mentioned that hey, I am trying to optimize this, and you have a better solution O of n. Can you do a better approach with O of n? And it turns out yes. So how we can do approach, who has a time complexity of O of n? How can we do this? Now imagine that you have a number. I'm not picking out any numbers here. I just wanted you to imagine that this is an array. Now within this array, you wanted to have the value corresponding to this as multiplication of all of these numbers, right? And that's where and for this number, let's say, and for this number you want to have a multiplication of this and this. So this multiplied by this gives you the answer. So I would say if this multiplication is this is x and this is y, then x multiplied by y is your this answer. And that's where it clicks you that, hey, why can't I just have a prefix and suffix arrays? What do I mean? A prefix array which would just store the multiplication from the start to the end, and the suffix array which would store the multiplications from the end to the start, and it would be everything. So it would contain everything which would be required for prefix and suffix. Cool. So let's say this is a prefix array and I have nothing. So let's say this is a prefix array. Cool. And here goes our suffix. Oopsies. And here goes our suffix. So within this prefix array I don't have anything on the left hand side, so default is 1, default is 1 here as well. And suppose if I have here any number known as a, and here would be a because it is prefix, and if it is z over here, the suffix would be z. So in this way we can go ahead. So if it is b over here, so this is a into b, it is y, so y into z. At any time if I wanted to have a multiplication of any number, I can just check that, hey, this multiplied by this, it would give me a result of this. And yeah, this works very well. Now you're pretty much confident and you go ahead and say that, hey, I have an approach which would take O of n time complexity. Along with that, I would be having a secondary array of prefix and suffix, which is n plus n, which is nothing but O of n. And yeah, this is good, this seems good, but most of people just get stuck over here and they do not proceed and they just implement this code. But guess what, it is prefix suffix array. But guess what, you don't have to stack it over here, you need to go beyond this point. Beyond this point means there is an optimized approach, which we can say it is an optimized approach of prefix and suffix. Optimized. The problem here was we earlier had space complexity of O of 1 and here is O of n, and that's where the interviewer also tells you that, hey, your algorithm runs in O of n time and without using division operator, and can you solve this problem without any space complexity? And yeah, that is an issue because let's say with a good amount of time you came up with this approach and you don't want that, leaving the time complexity to be O of n, and now there's a challenge, space complexity should also be O of 1. How can you solve this one? Now let's understand what went wrong within the earlier solution when it comes to prefix and suffix. Now you know that, hey, you are storing a prefix and suffix array within here, which you don't have to because you're traversing from left to right, from 0, 1, 2, and at any moment of time you don't want. So let's say if you're at this point, do you want what is there on index 0? Do you want index 1? No, you don't want. You just want what is at my previous index. So why we are storing this one? We don't need that one. So remove this. Do not store prefix just store an element, just store a variable mentioning prefix multiplier, and that's it. And that would be responsible to take your elements one by one, multiply it, and maintain itself. So well, that is solved. Now we have removed one n. Can we remove another n? Well, the answer is tricky. If you wanted to do that, you need to parse it from the right as well, but you don't want to do that. Well, you can do that, but again, you can need to take another iterator, and to maintain that iterator you need to use division operator, which is not required. You can do one thing, that you are anyhow creating an array, which is a result array, right? Because you are returning an integer array. So you can do one thing, that you can just store whatever you have within that array. So suffix array which you need can be fulfilled with with the result array. And how does it work? Because if you're going to fill this element, I would first of all remove this element, because suffix means I just want terminal elements, ending elements, and I don't want previous elements, and that serves a purpose. So till this point you have till this point you have actual result answers, and from this point you have suffix. The moment iterator shifts on to the right, this point, you have results till this point and suffix till this point, and so on. So each moment your answer increases and your suffix decreases. That's what is happening. And yeah, it is awesome. Now you have not used any auxiliary space, your time complexity is also of n, and now you can do the solution. So with that in mind, let's have an answer, which is a dot length, and I'll just call it as a, or instead of that I'll just take it as n, where final int n is equal to this, and I would return result here. Within all of this, I would go ahead and just take suffix populate. So suffix population goes here, and you know the suffix population, how it works is or I would say just prefix population. You can do both the ways. Prefix population is much more simpler. I'll take 1 less than a dot length plus plus, and if you are doing that, let's fulfill arrays dot fill result with 1. Why I'm doing this? Because default value is 1. Let's say you are at element 1, index 0, the default value you have is 1, and since I'm starting from 1, I want to take result of I is equal to result of I minus 1 multiplied by the current element a of I. Oopsies, a of I minus 1, yeah, because it is prefix, right? And from the right, I would take 1, so right multiplier. It is obviously an integer. I can fit that into integer because again all the multiplications are within 32 bits. So for int I is equal to n minus 2, I is greater than or equal to 0, I minus minus. So I'm just back populating. This is a bit different because I have used earlier a suffix, but now I'm saying that hey, don't use suffix, use prefix. Both sides work. I have explained it very well, so you can directly implement such kind of approach, but if you want to implement it with prefix, I'm just doing that. Now right, which is responsible to keep the right multiplications, the multiplications on right hand side, or in case suffixes, I'll just take a of I plus 1, because obviously I wanted to go on the right side, and result of I is equal to multiplied equal to, so what would be the result? It initially is the prefix, so prefix is already done, I wanted to do with suffix, and who holds the suffix? It is the right. And that's it. I can compile this code, and yeah, it says accepted for initial test cases. Let's submit it for rest of all the test cases. And yeah, it has been accepted with the time complexity of O of n and space complexity of O of 1. Do not get intimidated by it beats 94% or not, because the top solutions as well carries the same thing. Okay, this guy done a hack for using a static, but again, may be cheating, may not be cheating, I don't know. But the time complexity still remains the same. Left product, right product, still the same, everything. In fact, this guy used the same technique which we did. Nice. So cool. This was about it, the prefix sum, suffix sum. But if you wanted to compare strings and you have only few constraints of swapping, and you wanted to check whether two strings are equal or not with these limited swaps, click the video on your right, and I will see you in the next one.